So in this video we get directly into the subject, the very important subject in logic of truth tables. So the truth values of a compound propositional form, please check the previous videos for this, are obtained by exhibiting all possible combinations of the truth values for its components in a truth table. Okay, so we saw in the previous videos we had two propositions, proposition P and proposition Q. Okay, so we are going to do truth tables for this. So we have P and we have Q. So we only have four possibilities. Either P is true and Q is also true, or P is false and Q is true, or true, false, and false, false. Okay, let me erase this. Okay, so let us take the table for P and Q. So this is the AND, right? So truth, true, they are both true, so this one is true. False and true, so P and Q, so one is false, so this one is false. And obviously they will all be false. Okay? So these are the four combinations, right? This sentence is true, this one is true, or this is true, this is false, this is false, this is true, this is false, this is false. And since this is P and Q, it's only true if both are true. Okay, I'm going to do using this same P and Q. Let us do it for P or Q. Okay, so we only need one of the propositions to be true. Okay, if P or Q is true, then this proposition is true. So P or Q. So true, true, so this is true, true, and those two are both false, so this one is false. Okay? Okay. There is a table here that is a bit different. The table for P and not P. Okay, this table is different because if this is true, this one is false, and if this one is false, then this one is true. Okay, this is a different table, a very easy one to do. Okay, because the value of non-P depends only on the two possible values of P. Okay, so this is the table for P and not P. Okay. So you might get more than two propositions. You might get proposition P, proposition Q, and proposition R. Okay. So what are all the possibilities? This one is true, this one is true, this one is true. Then let us say true, true. Let us do this one false. Okay. Now true, false, true, or false, false, true. That's another possibility. True, false, right, and if I'm not wrong, so this is true, false, false. I think there's no mistake here. And the last one, okay, true, true, true. So this one will be false, false, false. Okay, let's do a table now for P and Q, for instance. Okay, so P and Q, so true, 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 obviously true, and this is P and Q, right? So false, since this one is false, this is false, right? True, false, so this is false. False, false, so false, because this one is true. Those two are true, true, so this one is true, right? Because it's only P and Q, okay? Oh, P and Q, we are not counting R now. Okay, P and Q. So false, true, right? So this one will be false, true, false, so this one will be false, and false, false, this one will be false. Okay, let us make a table for not R. So this one is true, so this one will be false, right? False, right? True, so this one will be false. True, this one will be false. False, 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 false. So here, true, 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 true. Okay? Now let us say we have a proposition like P and Q, okay, or non-R. So we need this table now to be true, or this one, okay? So this will be true if either one of these is true, okay? So this is really easy, and this one, P and Q, is true. And how do I know that P and Q is true? Taking this table here. Okay, this is the table for this one, okay? In a certain way, we are using a recursive method, okay? So this one is true. So false, false, this one will be false, 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 right? And now true, 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 false, true. This is OR. So this is true, false, true, true, false, true, true. Okay, here you have this compound proposition with 3 propositions. So P and Q first. My first idea is I say P and Q or non-R. Okay, and mind the brackets, because obviously the brackets, they change everything. Okay,